This is again, I'm a singer, eternal voice. So welcome back to my science vlog. Okay? Kumusta kayo mga palangga? Okay. Okay, mga kapatid. So let's go now directly to the topic. This is dilution concentration in terms of the expression of the concentrations could either be molarity or normality, molarity, and the rest of the expression of the concentrations, then with the mixture of stoichiometry, molar stoichiometry, dilutions, like that, solutions, mixtures, dissociations, neutralization, and a whole lot more. It's gonna be multiple, but related really to expression of concentration. Okay, let's go now. Question number one. Okay, so this is very useful also when you make a product, then you have to dilute it, to concentrate it, like that. Okay, so question number one, how many milliliters of water must be added to 100 milliliter of 0.80 molar or moles per liter of the solution of potassium hydroxide to dilute the concentration to 0.20 molar. So let's agree first, dilution. Okay, dilution. Okay, meaning it involves, the addition of a water in aqueous solution, or it could either be two solvents mixed together, something like that. Okay, so we have here solution. So solution one is equals to solution 2, like that. Okay, and then or either mixture 1 is equals to mixture 2. Okay, so take note the difference, because if that is a solution, okay, we are referring both the solute and solvent in solution 1, solution 2 also solute and solvent. Okay, mixture 1 solute and solvent, mixture 2 solute and solvent, like that. Okay, or not necessarily solute and solvent, 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 like that, or solute, solute, like that, as long as this is a combination already. Okay, because in the problem, we will be confused with the volume. Sometimes we will interpret that this is only the volume of the solute, where in fact that's the volume of the solution. Okay, get the point? So here is how many, okay, mga palangga, how many, okay, how many milliliters of water? Oh, we are very lucky because water only. Okay, must be added. Okay, like that, to 100 ml of 0.80 molarity or molar solution. Okay, of potassium hydroxide. Solution of potassium hydroxide, meaning the water is already added there. Okay, to dilute the concentration, to 0.20 molar or moles per liter. Okay, so we are asked for the volume of the water. So volume of H2O. Okay, that should be added to 100 ml of the solution. Okay, like that. So that's the required. Now here we need to follow the dilution formula standard. In 1, V1 is equals to N2 V2. So our one here is the potassium hydroxide, right? Okay, potassium hydroxide. This one all about potassium hydroxide. So I will say M times V parentheses potassium hydroxide. Okay? Or you can say only that this potassium hydroxide is you refer to one. Okay? But I prefer like this because I mentioned really the specific chemicals. Okay? And then we have MV. You don't know. Why you don't know? Because it's not mentioned in the problem. So we need to say you need to have a new mixture or a new solution through chemical reaction. So for example, if you add water, so we have 100 ml of this solution of potassium hydroxide. It's gonna be reaction. We are now having a chemical reaction, mga palangga. Okay, RXN. Oh. Okay, we have potassium hydroxide. So potassium hydroxide plus water, because you add water, right? Like that. And then take note. Okay, this is water. And what is this potassium hydroxide? This is evidently a salt, okay, or a base, like that. So this is hydrolysis chemical reaction. Hydrolysis chemical reaction, adding water to a base or adding water to a salt. It's just the same to produce acid and a base. Okay? Like so acid and a base, we have already the productive products, acid and a base. So in here, double displacement or replacement chemical reaction. So the H2, like that, the H here will give or donate the proton, something like that. Okay, you got the point, mga palangga? So it's gonna be, okay, this is gonna be 0.20 potassium hydroxide. So it's gonna be like that. So it will be shades. Okay? So it's gonna be like potassium hydroxide. It's gonna be potassium positive plus hydroxide negative. Ganon. Dissociation chemical reaction. Okay? How many milliliters of water do I do? Okay, so, substituting the values now already, we have the molarity. Okay, 0.80. So, molarity of potassium hydroxide solution, ha? Okay, so 0.80. Ganon. Okay. And then the volume, this is 100 ml of that solution. So, 100 ml. Okay. Now take note, guys, if you multiply the 0.80 moles per liter to 100 ml, it is not compatible. So in my case, before when I was in college, I always convert first the milliliters to liter to match, but actually it's just the same. If you are having ml on the other side, you can cancel the milliliter even though you will not convert that into liter. But take note, what if the volume there is not given, the other two, or the concentration we'll have to find out. Then you have to convert. Okay? Good only if the concentration is being asked to the final solution of the new mix. So what if asked is also volume? Okay? So you should convert first this 100 ml to liter to make it sure. Okay? Because you cannot cancel already the ml in both sides. Okay? Because you can cancel both ml man siya if there's an ml in the right side and the left side, even though you will not convert this milliliter to liter to be compatible with the 0.80 moles per liter. Okay? You get the point. So, for me, I will convert this to 0.100. Okay? To make sure. Ganon. Okay? So, this is 0.1. 100 ml, 0.01, diba? 3 zeros. 1, 2, 3. 0.1 din. 3 zeros yun siya. Right? Okay, 100 divided by 1. Okay. So, this is moles per liter. And then times liter, so moles will be left. Okay? Then the new mixture, the new solution. Okay? We have the molarity is 0.20, so 0.20. Like that. Okay, and then we have ano siya, volume is unknown. Okay? So expected that the volume will be in liters. Okay? Like that. So moles per liter here, unit of concentration, then okay, then cancel the mole on the other side. What's left is liters. Okay? So volume is equal to calculator is okay, so 0.80 times 0.100, diba? divided by 0.20 is equals to 0.4. 0.4 liters or 400 milliliters, right? So like that. But take note, this is the volume of the solution, of the new solution. Volume of the final or new solution. Okay, or resulting mixture, like that. Okay? So, and you are asked volume of water. Okay? So it's very evident that you will have to subtract the total volume is equal to the volume you are going to add, ganon, diba? Okay, the volume you are going to add, which is unknown, okay, plus the volume of the solute, ganon, volume of the solute, okay? Okay. This is the total volume, 400 ml na naka, so substitute or 0.4 liter, you say 0.4 liters. Claro guys, okay. And then, you have the volume of water, right? Okay, not yet because you're going to ask that one. Okay, you don't have the volume of the solute here. Take note, this is 100 ml of 0.80 molar solution of potassium hydroxide. So our potassium hydroxide is the solute. So this 100 ml or 0.0 liter is our volume of our solute. We treat potassium hydroxide here as our solute. So this is 0.1. Okay, 0.1 liter. So the volume of water is equals to 0.4 liters minus 0.1 is equals to 0.3 liters, or 300 ml is the volume of water you will add to make it 400 ml, which is the resulting solution. So see, if you will not think it carefully, you will answer this 400 milliliter in this question. But take a look, how many ml of water must be added? Okay? It's not the solution is being asked. It's not like this. How many milliliter of solution will be the final mixture to add 100 ml like that? So it's water added kasi siya. So you have to determine the volume of water must be added to get your final mixture or final solution, 400 milliliters, something like that. Okay? Get the point? Any questions so far, mga kapatid? Okay, so later I will be explaining to you a little bit of, relationship between the concentration and the volume so that we can understand what will be happening somewhere along the way in our chemical reaction, right? Here mga palangga, actually, it will yield hydroxide because it is KOH when you put into the water, right? Like that. Yes. Ano siya. Then you should determine properly the proton donor, like that, the electron donor, like that. But we are not really concentrated for that. We are here to compute for the amounts kasi. Okay, we are not really measuring which is the bronzodoric acid, the base, like that. So it's not our target. So that's why I come to think with this chemical reaction. Okay, because this is a hydrolysis reaction, acid and a base, right? But if you add this water here, you will yield hydronium ion. You remember I stopped for a while? I think for an acid and a base, oh my gosh, where's the acid here? Where's the acid base here? And then, oh, like that, padayon na sa akong solution. But actually, I found it difficult to produce the acid because only one element here, okay? Metal here. Okay? Hydrogen is a gas, non-metal. Only potassium. And then if you double displacement that one, there's no other, there's no partner. You got the point? So you will say hydronium ion plus potassium hydroxide. Diba? Tawag mo guys. Oh, diba? I-double displacement, good ang inyo. Then siya would make material proton positive 1 or proton will be donated to the water, right? So, see, imagine your potassium hydroxide will be, since it donate the potassium hydroxide here is used as an acid. Really, right? So how dangerous is that? Nakakaloka, di ba? Ano sinitabo? Okay? So, amphoteric din siya. Okay? It depends on the situation. Sa ganito, when the compound can act as an acid and a base, these are all amphoteric acids. Okay? Same as when the metal can act as a, the element can act as a metal and non-metal. Sometimes they are also called metalloids. Okay? Get the point? So, if you apply that to the human being, so tawag ano niya? So, bisexual. He can act as a male, he can act also as a female. Okay? So, most na siyang metalloid, can act as a metal, can act as a non-metal. Okay? Most na siyang amphoteric substances, can act as an acid, can act as a base. Okay? Dual orientation. So, nagtuo mo sa tao, sa chemicals na apod, sa substances. Okay? Ganon. Okay. So, thank you so much guys. If you like this video, you can comment, you can like, and you can share, and you can subscribe to my channel, and then you can click the bell notification for some news updates. I am a singer and channel voice. Welcome back everybody. Oh, kinakakaloka, diba?